Good evening to all participants and welcome back to the third day of this 6-day online FDP. It is my honor and pleasure to welcome our distinguished speaker, Dr. Basim Khan, Associate Professor, Hawassa University, Ethiopia, who will be talking on the topic of space microgrids. Dr. Basim Khan is a distinguished researcher and academician with over a decade of experience in electrical engineering, specializing in renewable energy systems, smart grids, power systems, and the application of optimization and artificial intelligence techniques in energy networks. He is currently an associate professor in the Institute of Technology, Hawassa University, Ethiopia since 2015. Dr. Khan earned his Doctor of Philosophy in Electrical Engineering from Maulana Azad National Institute of Technology, Bhopal, India in 2014, where he also completed his Master of Technology in Power Systems in 2010 and Bachelor of Engineering in Electrical Engineering in 2008. He is further enhancing his expertise through postdoctoral research in electrical and electronic engineering technology at the University of Johannesburg, South Africa in 2024 and as a postdoctoral associate at Universidad Internacional Ibero-Americana, Mexico 2023. With over 11 years of teaching and research experience, Dr. Khan has collaborated internationally, including projects with Aalborg University, Denmark, and held research positions at Western Caspian University, Azerbaijan. His prolific scholarly outputs includes more than 400 research papers, 10 books, 50 book chapters, and 6 patents. His work has earned him numerous accolades, including being listed among the top 2% researchers in the world in the year 2023 and 24 by Stanford University and receiving multiple Best Paper awards at prestigious IEEE conferences. Dr. Khan is recognized for his leadership in advanced energy research, impactful teaching, and significant contributions to the development of sustainable and intelligent power systems worldwide. I now request Dr. Basim Khan sir to please start with his session.
Hello, good evening to all. Thank you very much, Professor Deep, for providing me this opportunity. I'm really thankful to Dr. Nilesh for this nice FTP program. And I personally feel that such programs are very helpful to exchange the knowledge and the research which is going on different part of the world there. And I think this particular program is basically related to the patent and related things. In that, actually, my area is not very much aligned with that, but that is also related to some research and how we can go for further in the enhancement of research technology and how we can implement these things in the form of patent and all that thing. So we will discuss this also in this particular presentation. So thank you very much for this opportunity. And now I'm going to start my presentation. Okay, so as the today's topic is a space microgrid, and we'll discuss about what is the present and future trends are there. So basically, microgrids we all know, because I think most of you guys are belongs to electrical engineering, and we know very well that what are the grids. And grids means the system which is provide, generate, transmit, and distribute the electricity. In a similar manner, the system which generate the electricity at the micro or small level, we call it a microgrid. So space means definitely the system which is not on the earth, maybe in somewhere extraterrestrial place where it is generating the electricity with the help of some renewable energy sources. We simply mention it as a space microgrid system. Okay, so in this particular system, I will discuss about what are the different type of space microgrid systems are there, what are the problems with them, and how with the present research, me and my research team are going to overcome those issues there. So like that way, I will complete this particular presentation here. This is the outline of my particular presentation. So space microgrid. So we are now on Earth, and so many space agencies, they are planning to develop some base stations on moon and then further on Mars also. And we call them, if it's on moon, we call it a lunar base stations there. And what are the different things available if they are going to succeed for the development of such lunar base stations? So definitely there are three major part will be there. The first one will be the lab. There will be some laboratory will be there where the scientists will perform the research. The second part will be the habitat, where the different scientists will stay there. And the third one will be the ISRO. I will later part of this particular presentation, I will discuss that what is the ISRO is there and why that is very, very important for the perspective of a moon or lunar base station will be. Further, if we go for the more deep in space, so we have a Mars, and there are space agencies like SpaceX, NASA. They are planning for the development of some Mars-based stations also there. Like they are sending so many rovers there and just want to collect the information from the Mars surface there, Mars atmosphere there. So maybe in future we will see there also. In future there will be some base station they will plan there also. So till now whatever the information we got about the moon surface or moon atmosphere, it is from the NASA Artemis mission is there. They completed this mission, and under this mission they have performed so many research activities there, and by that they collect all the information on the moon surface. They summarize those all the information in the form of some documents, their reports there, which you can also download from the NASA website. You simply type the NASA Artemis mission, and then you will get all the information related to that particular plan there. Even though in our work also till now, whatever we have performed here, the modeling of different sources there, the renewable energy sources modeling, modeling of different types of demands, the distribution network, whatever thing till now we have also performed, we also downloaded those documents actually, and we have modeled the system based on those documents. Okay, so if anybody is interested in that, he or she can download those things from the NASA Artemis website. All the files are openly accessible and you can download in the form of a PDF there. So now we comes on the our main topic, that is what is the space microgrid there. So like it's enable the sustainable energy for the habitats, life support and scientific instruments. As I already mentioned that if you are going to develop the space microgrid system for the lunar base, definitely it has a habitat load, life support system demand, and the scientific instruments inside the laboratory will be there. Then we have some critical missions beyond the low Earth orbit also. So at those missions also we required some uh, energy, and for that also the system or the grids which we develop, we call it the space microgrid. So the definition is simple there, but the issues associated with this space microgrid system is more complicated there. Like for the space microgrid development for the lunar base station has the first challenge, and that is what dynamic environment there. Actually, on the moon surface, there is a continuous 14-day day and 14-day nights are there. That is the very, very dynamic environment is there, and very difficult environment also. Why it is very, very difficult? Because during the daytime the maximum temperature sometimes reach to uh, plus 150 degrees centigrade also there around that, and during night time, which we call it the lunar nights also, it will reach to minus 120 degree also. So like that there is extreme variation in the temperature is there on the lunar surface during the day and during the night time. So that is the dynamic environment. So if you want to develop any base station there, definitely you should provide solution to this dynamic environment, and then only you are able to develop the base station there. So that is the first thing. Second thing is related to the resiliency. Now, on Earth, if you develop any system, if something happened, also some fault or some abnormality happened there, means it's easy to maintain that particular system. But if you are going to uh, develop that system, maybe somewhere in the extraterrestrial orbit, then it's very, very difficult. Because why it is very, very difficult? You cannot send a human there to just repair the system each and every time there, because the mission cost is very, very high there. So this is also a place where we can incorporate the artificial intelligence techniques, so that the human intervention will be as limited and as possible, and with the help of artificial intelligence, we can make the system more autonomous there. Because what is the advantage with the artificial intelligence techniques, like whether it's CNN or whether it's LSTM, there are different types of techniques there. So the advantage is you can predict the fault in advance, and you can easily find out that how to avoid such fault, and if the fault is also happen, how you can just isolate that system and then reconfigure that system and again make the remaining system in the working condition. So that is the main thing in the fault resiliency, where we can incorporate the different artificial intelligence model and perform the task there. That is the third place where we can also incorporate the artificial intelligence techniques there. And I think somebody mic is on. Yeah. So the third key challenge for the space microgrid system is the limitation of a energy storage system. Actually, if you are if any agency planning lunar base station also, so definitely what are the available sources on moon? The first one will be the solar is there, and when there is an excess amount of solar is available, definitely you will store that amount in the form of a battery energy storage. Or when there is a lunar night is there, definitely at that time you should use these battery energy storage system and supply to the demand there. That is fine. But you know very well that the weight of these whole battery energy system is very huge, and that cost is also incorporated in the mission cost. Okay, so that is the major thing. Whenever SpaceX or the NASA, they are planning such type of maybe they are planning first lunar base station in 2026 or 2027. They are also very near to that lunar base station actually. So in such thing, the weight of any component is also play a very critical role there. So with the help of artificial intelligence techniques, we will try to minimize such energy storage capability as much as possible. Try to incorporate the local sources there. In the further slides, I will let you know that how we can incorporate the locally available resources at the moon surface there, so that the overall requirement of a battery will be greatly reduced, and the mission cost also greatly reduced there. So the efficiency of a whole mission will be greatly enhanced. So these are the three key challenges we should address whenever we are planning for this lunar base station. Now, how you can go for these three problems if you want to incorporate the artificial intelligence techniques to solve these discussed issues. So the first one is the hybrid optimization technique you can incorporate. So for what purpose you can incorporate them? So for the load balancing, as we know very well, inside the power system, we have a thumb rule that always at any time instant the generation always equals to or greater than the available demand is there. So that is the thumb criteria we should follow here also there. Secondly, if there is any abnormality occur in the system, or the system detect that any abnormality maybe in future also come, so that faulty part should be removed from the system, and at the same time the system should be able to adaptive one and reconfigure the system after disconnecting the faulty part there. So these things we can perform with the help of a hybrid optimization technique. Second thing which where we can use the artificial intelligence technique is the energy management. Okay, so general meaning of energy management is what there. In energy management, we have a simply hierarchical control is there, where primary, tertiary, and the primary, secondary, and the tertiary control techniques we are utilizing there. So here also, for the energy management of a space microgrid system, we will utilize the optimal control for a space microgrid system. So at that particular place also, we can utilize the adaptive uh, microgrid controllers, so that they will be able to control the microgrid in a more efficient way there. Also, they will manage the generation and the demand which is available at the space microgrid system. The third task is very, very important one. As we know very well, nowadays at a different sector, artificial intelligence models are utilizing. And why they are utilizing there? Because their forecasting accuracy is very, very high. It's around 99.9% also. Sometimes they will provide that. And when we are planning any mission, it's always required that the prediction or the forecasting should be as accurate as possible. Otherwise, there is very high chances that whole mission will be failed there. Similarly, when we are planning to develop this lunar base station also, we should able to predict the solar generation on the moon surface by using the time series data. So this prediction also required what then? This prediction also required the artificial intelligence model. Second thing also, we require the spatial analysis for the dust accumulation. Actually, we know very well that on the moon surface there is no atmosphere. Is correct or not? On Mars there is a atmosphere, but on moon surface there is no atmosphere. But still there are showers of meteoroids there. So sometimes what happens due to those showers, those meteoroids, they are simply uh, form of the dust is there, and they cover the solar cells. And due to that also, the efficiency of a solar plates will be greatly reduced there. So we also required some method so that we can forecast that dust accumulation in future, because we are not on the earth. If we are on earth means it's easy. We can simply develop any motor based mechanism there which can clean those solar cells. But when you are on the moon surface, you should uh, count 1 gram weight also, whether it's a dust removal system is there, maybe that motor which we are utilizing to clean these solar cells. So each and everything should be counted there. That's why this prediction also very, very important there. So generally, artificial intelligence techniques we are utilizing for these two purposes. First is just predict the solar generation, and secondly for the dust accumulation. At last, for the fault detection, as I already mentioned, the fault which going to be happen in future should be anticipated in advance, so that we will be able to detect, uh, classify, then isolate, and then again reconfigure the whole system. So these four tasks should be performed in advance whenever the fault will happen, so that the remaining system will be in proper working condition there. So these are all are the four tasks which we can utilize or solve with the help of artificial intelligence technique. Here, one more extra task is there, that is the condition monitoring. Actually, that is also very, very important in terms of a space microgrid system or lunar base station. Why? Because what we understand by the condition monitoring, actually, on the lunar base station, there is a one system we will going to develop there, that is called the ISRU. ISRU resource utilization unit is there, which utilize what? Which utilize the moon rock or moon dust for the development, or what? For the development of oxygen and water there, because it's captures some amount of hydrogen and oxygen there. Okay, so we are utilizing that particular dust. Now, how you can utilize this particular dust, which we call it regolith? This regolith actually required to crush. When we want to crush that regolith, what we required then? We required some type of motor there on the moon surface. And when motors are working on earth, that is okay. We have a normal atmosphere there, not so much extreme weather condition there. But on the moon surface, the weather condition is extreme one. High temperature and low temperature, both the conditions are available there. And under such condition, the machinery will greatly affect its performance, working performance also greatly affected there. So in future or in advance, we should monitor that condition of a particular machinery there. So we will do it what here? Here also we will utilize some artificial intelligence based models, and we simply find out the future conditioning of a particular motors there. Okay, so we will monitor here conditions, okay, of a different motors which we are utilizing under the screw. Now the problem is what there when you are going to work on the software system. The problem is you can validate the system on software, but if you want to practically implement that system, then the problem is what, till you are not implemented on the hardware based system, you cannot find out what is the actual problems there. Okay, and it is very difficult to find some hardwares also there. But now presently I am working in a space research laboratory in China, and there actually we have a typhoon based HIL system is there. So now what we are doing, already we finalize our software based model there, which we develop inside the typhoon software in loop system, SIL system there. And now we are in the process of development of this SIL system to validate it on this typhoon HIL system also there. So we are utilizing the real-time simulator. Already there are two DSP controllers are there available inside this typhoon, and some sensors is also there. So by this we are just going to validate it soon. So this is the overall actually task which we are going to perform here. We are utilizing some artificial intelligence techniques, whether it's a CNN, NSG or LSTM, and we implement on the developed space microgrid system. And then once we implement on that space microgrid system, we are going to develop advanced AI based control, efficient energy management system, and enhanced microgrid operation will be. And these are the research tasks actually we are working on that. So first three tasks we already completed. We are on the fourth task where we are going to implement HIL, that is the typhoon one. And after that, we are going to full system stress testing of the developed model. So this is the system actually we have developed inside the SIL of a typhoon there. So if you see here, we
Excuse
have
me, sir.
yeah.
Sir, the screen is quite hazy. Means the alphabets and letters are not clearly visible. I think it might be because of some network issue also.
Now it's okay. Shall I disconnect and connect it again?
Yes, sir. I think that may clear the issue.
1 second. Now it's visible.
Yes, sir. Now it is clear, sir.
Actually, I am not in China. Presently, I am in Azerbaijan and I am in the hotel room. So maybe there is some issues there.
Yes, sir. Yes, sir. Okay, now it is clear, sir. Thank you,
Okay,
sir.
that's so. Please cooperate. Okay, so this is a model actually we have developed in our laboratory, and in that particular model, we have utilized the solar system and regenerative fuel cell, battery energy
चाइना
storage
में नहीं
system.
हूँ,
So
अजरबैजान में.
three systems we are utilizing here. PV, RFC, and the battery here. Okay, and to control these all the three resources, we utilize the three AI controllers. So for PV, we utilize the artificial intelligence based MPPT controller. For battery also, we are utilizing one controller here, and for RFC. Actually, whenever we are talking about the space mission, the most reliable source of energy generation is nuclear reactor. There are small type of nuclear reactors is also available, and basically in reliability that will be the best one. But the problem is what if the mission is failed or mission is complete after that, the management of such nuclear reactors is very difficult there. That's why the United Nations agency, which is just to control this space missions and space related things, they mentioned one rule in their gadget that till in any space mission renewable energy waste sources are available, there is no need to utilize the nuclear there. But for a deep space missions means you are going to Plato or maybe more deep inside the space there, and where the solar energy is not available, there places you can utilize the nuclear. So in our work presently we are not utilizing the nuclear reactor there. Okay, and we are going to utilize this solar regenerative fuel cell and the battery energy storage system, and we utilize three different controllers to control them. And as I already mentioned, three different types of load will be available there. So the first one will be the NS2 resource utilization unit load. There will be some motors will be there, which is required to crush the regolith, the moon dust. Then secondary will be the laboratory load will be there. And third will be the habitat load will be there, where the scientists will stay there. So that model we actually develop first in the MATLAB, and the same model we interface with the Typhoon SIL. And now we are in the process of hardware and loop system. So this is the model which we already developed inside the MATLAB also. And when we are going to energy management system there are some other subtasks will be there, which we are going to utilize it. Like the first one will be the DC voltage stability enhancement. As the whole system we are working on is DC, because we are just taking the energy from the solar there, and the loads also which we connected generally are the DC one. And for the regolith also, for crushing regolith also, we are just considering that motor also, the DC motor only there. So like that way, different types of loads we are considering. The generation also we are considering is a mainly DC system we are considering there. So that we required what there? We required the DC voltage stability enhancement. So this is the one subtask there. Second one will be the load sharing and the current control. Third one will be the fast transient response. Fourth is the redundancy and the fire fault isolation. And the fifth one will be the optimal energy schedule there. So four different levels we will be considered for that. First one will be the core level one, where we are going for the management, life cycle management, and the corrective and the preventive maintenance system. Second one will be the proactive, that is the level 2, where we are just monitoring the performance based monitoring system and the predictive maintenance again here. Third one will be the advanced level, where we are going to peak load forecasting and the voltage regulation. And the last one will be the premium one, where we are going to develop the digital twin and the virtual power plant there. So this is our 4 level where we are going to be work there. One more thing where we are just make some modification there, like along with the artificial intelligence techniques like machine learning or deep learning, we are also incorporate some human brain models in our laboratory. There are some researchers are there from the Denmark, Aalborg University. Their research on the replica of human brain development is there. They are developing the human brain model there. So now what we are doing here, we are merging those human brain models with the machine learning models and try to get the more better answers for these already discussed problem there. And these are the 4 subtasks till now we already completed there, 5 actually. Like the first one is the hierarchical control of closed ecosystem for the space mission is there. Here we develop a one closed system, closed ecosystem. Closed ecosystem is a system where the energy, food, water, and air, all these 4 things will be generated inside the one closed loop system. And this system we have control with the help of a hierarchical control system. So we already completed that. For the development of this CSE also, we use the NASA data and we develop that, and then we utilize the model predictive control techniques there to control this closed ecosystem then. Secondly, we will go for the optimal sizing and siting of a PB RFC battery based space microgrid system, because on the moon surface also there are different locations are available, especially on the south pole of a moon, where there are so many craters are there. So on those craters, the PV illumination or PV irradiance are very high. So we will find those locations there. It is already available. Then I will show you in the further slides. We have performed one research there. We have just find out 10 different location on the moon south pole there, and then under different tracking techniques we just utilize 4 different tracking techniques and then compare all these 10 locations based on the generated PV values there. So like that, the second task we have completed there. In the third task, we will utilize the artificial intelligence based method for the battery energy management system. And in the fourth one, the data which we have developed with the help of a previously discussed model, we will find out the robustness of that particular data. Also in the laboratory, we have developed one prototype. It's a 2 CubeSat is there. So one small model we also developed there. So this is the first task, subtask which we have completed, where we utilize the model predictive control technique for the controlling of a closed ecological system. Here, 5 different level we will utilize there, where we are just optimize the air, water, energy, and food subsystems. PV, battery, and RFC sizing is performed, and different critical load prioritized there. Simulation is performed for the 28 days whole lunar mission, means 14 days days and 14 days night. Okay, so like that way, total 28 days will be there. Actually, these 28 days lunar mission, we will also take this reference from the NASA or the European Space Agency data. Actually, that is already available there. Their missions also related to these 28 days lunar missions is there. So we also utilize the same 28 days duration there, in which 14 days are the day, lunar day, and 14 days are the lunar night will be there. So this control strategy enables a mass efficient and survival microgrid suitable for both lunar or the Martian habitat will be there. And in the second task, we will go for again PV panels, batteries, and RFCs optimization. Their sizing optimization will be there. This particular task also for the 28 days full lunar cycle will be there. We will utilize the mathematical optimization techniques for the purpose of finding the most optimized solution. We also incorporate one thing here, that is the radiation degraded PV performance. As you know very well that on the moon surface, the radiation value is very high. So we also incorporated that particular value of radiation, that what is the impact of that particular value on the performance of a PV battery electrothermal behavior. Because when battery is there and the atmospheric temperature is very high, then all that temperature also affects the performance of a battery, we know very well. Also the low temperatures also affect the battery behavior. So we also incorporate the battery performance under such extreme temperature variation there. Similarly, for the regenerative fuel cell, we will calculate the round trip efficiency there. So this particular sizing strategy incorporate 3 things there. What is those 3 things? The first one is the PV sized base irradiance and the conversion efficiency. Second, battery size to cover the 14 days night period. And third one, the RFC size to complement battery limitation, provide backup energy. Basically, in this whole work, we will utilize firstly when there is lunar night there. So battery will start supplying to the different demands there. And when there is a requirement and battery energy may be going to finish soon, then we will just start our regenerative fuel cell system as a backup one, and then just complement the battery energy storage system there. So these things we will perform here. Here mainly the advantage of this work, why we perform this task, actually we incorporate the radiation effect on the PV and the battery performance, also the extreme weather performance on those systems, so that we can actually accurately measure the generation, what are the different changes will be available on our generating station, on our generating system, so that we will incorporate these things in a future research there. So this is the third subtask which we have performed there, where we will incorporate the battery charging management system there for the lunar operation here. So in this particular thing, we will just incorporate or extend the battery life and its efficiency by minimizing the degradation due to the variation in the temperature there, gassing effect, and the energy losses during the charging cycle. Controlling strategy also incorporate there, where we have a temperature compensated charging and individual battery regulation. Then this system also incorporate the real-time SOC, state of charge, and SOH monitoring, state of health monitoring there, thermal protection, fault detection inside the battery energy system, and both active and passive cell balancing will be there. Then the simulation confirm that performance under this condition, scalability for the small rovers to lunar base station compatibility with Artemis on the RFC integration. So the subtask which we have performed by our battery energy charging system confirm that the developed system can be supporting or in line with the Artemis mission specification and can be easily incorporate the RFC there. Now, the fourth task which we have performed, that the data which we utilize from this particular developed system is there. We have computed the data of a PV, battery, RFCs, different loads. We will compute that data. Then what we found out with that particular data, that whether this data is replicate the actual Artemis mission specifications or not. So for that purpose, we will utilize some machine learning algorithm and then find out the robustness of a computed data from the developed model there. So this is some futuristic pictures of lunar base stations there. Like in this, we can find out that there is excavation of a lunar surface for the purpose of getting the regolith, and then this regolith utilized for what purpose? For the purpose of generating oxygen and water there. And this whole system is generating for 4 crew members, and at least for the 28 to 30 days stay for 4 times per year. So this system maybe in future we will be see on the moon surface there. So these are the advantages of space microgrid systems there. If we are going to develop this system on the moon surface, so the first one is the reliability and resiliency. Definitely, if you are providing the energy on the moon surface, it's a reliable one because we are supplying near to the demand only there, and continuous operation is also possible there. Secondly is the flexibility and the modularity will be there, because it's easy to increase the number of solar PV cells or number of battery stacks there, because we will in advance provide that. Okay, how we will decide those things? So definitely with the help of available demand, we have a 3 different types of demand, and we will further utilize some artificial intelligence techniques to predict the future demand also there. So by incorporating those future demands also, we are simply provide those solar cells and the battery energy storage system, so that the flexibility and modularity will be available there. Third task means definitely we are incorporating the available renewable energy sources, which is widely available on the moon surface there. So the requirement of a nuclear or maybe large battery site will be greatly reduced there. Definitely there is no transmission required. So only generation and the distribution is there. So transmission losses are greatly minimized there. Further, we are utilizing the different artificial intelligence techniques. So definitely the efficiency will be increased there, and safety also we are going to enhance there by simply utilizing some predictive models there, which can be predict the future faults there in the system, and in advance we are able to avoid them. Now, this is a task which we already completed, in which we are going to utilize the AI model for the purpose of fault detection and the diagnostic. So in the first step, we are utilizing we are supplying some input data. where different types of features are available. Maybe the 10 features of a solar PV data will be there. We will simply supply this, process this particular data in the first step. Then in the second step, we will utilize the feature engineering, where we will utilize some transform techniques like for fast Fourier transform or wavelet transform. So out of 10 features, we are going to select most critical features there, maybe the 5 or 6, which have a more impact on the final output there. After that, we will just collect or modify the data in a standardized manner. If data is sequential data, long sequences will be there. Then we will simply split this data into small sequences there. So that will be the third step. Then in the fourth one, we are going to develop the network. We are going to perform the network mapping there. For that purpose, we utilize the supervised learning, and we will just perform the training there. And then when we are performing the training, if we got this overfitting problem, we will tune the hyperparameters, and then we will perform this particular task there. So the same thing which I discussed in the theoretical way here is performed in this particular research papers here. That is a step one. We will just provide the data here. Then step two, we are going to feature extraction there. Then step three, we are standardize the data, then split the data, then train this particular model with the help of a different long short-term memory layers there. And then finally, we will develop the LSTM model with the best accuracy for the release there. So that the relays, intelligent relay will do what here? They will detect the fault and then simply isolate them and then reconfigure the available system there. So we also utilize different types of AI models for the forecasting also. So there are total 4 types of forecasting which is possible in this space microgrid system there. The first one will be the very short term, which is related to the few minutes to the hours is there. And the short term will be there, which is related to few hours, and medium term hours to the days, and then long term, which is greater than a month is there. So for a different approach, you have a different methods which you can utilize to perform this forecasting task here. And this is the our recent task actually, which we already performed. In this particular task, we are also going to just develop some forecasting model, solar forecasting model there. We will just forecast that in the form of a time space there. We will supply 2 different types of data here. That is the PV data and the meteorological data. These 2 data we will supply there. So this data we are going to supply for the pre-processing, because this is a huge data and we require to pre-process this particular data there. So we will pre-process the data, then normalize the data on the common base there. Then we will just find out the correlation between the different variable there. And then after that, we will just select some features there. Then further we will go for what? We will go for the initialization of the regression model there. So we will initialize the hyperparameters by some initial values there, define these hyperparameter space there, their ranges we will define there. Then we will utilize some artificial intelligence technique there, Gaussian, then RS, then the Bayesian optimization, we will utilize them. Then we will go for the model optimization of a decision tree, then model optimization for the support vector machines, then model for optimization for SVM again. Then we will again utilize or optimize this model for the trees there. Then further we will go for the neural network, and this whole data we will further supply for the again GS, RS and BO checking there. Once this whole data is developed, we will fit this model for the training via the GS, RS and the Bayesian optimization there. Validate this particular model performance using cross validation techniques. Once this model is developed, we are going to test this particular model there. So for testing, definitely we have some matrices there, and those matrices are related to the accuracy. And whenever the accuracy term is coming, so we will calculate the errors. The different types of errors there, like mean absolute error, mean square absolute error will be there, root mean square error will be there. So different error matrices we will be compute there. Then we will perform the solar power forecasting there. We will collect all the meteorological data, pre-process the data to match the model input format, train the Gaussian regression model then, and finally we will find the solar power forecast there. So this is the task which we already completed. Now, presently, we are working on a new concept there, where we are planning to develop and modify the existing ISRO models there. Like in two resource utilization models will be there. Actually, what we are doing there in this particular model during the lunar daytime, means when 14 days lunar day is there, what we are doing, we will generate the electricity from the solar PV system. Okay, fine. And then we store that energy in the battery energy storage system also. Then at the same time, we are also storing that thermal energy in regolith also there. That's why we just give the name here, hybrid photovoltaic thermal regolith fuel cell system for the lunar base station will be there. Okay. So here what we are doing here, we are supply this thermal energy for this regolith there, store there, and when the night, lunar night, 14 days lunar night will come there, then what we will do there, we will simply utilize this heat energy, the thermal energy which is stored in the regolith. We will supply this for the fuel cell, and then fuel cell will be able to supply the electricity there. So this is the plan. Actually, we are doing it. We are working on that. And when we implement this particular technique here, we get really very good results, and the amount of battery requirement is also greatly reduced there. So maybe we are already performed this on the software basis, but now what we are doing, we are just planning to implement this particular system on the particular hardware in loop system also. Once that is validated and full stress testing will done, then we are planning that maybe in future we can recommend this. So like that, here we have a key numbers here which we get it from this particular simulation here, like PV thermal. So we have a generated energy is this much here. Days PV thermal, again this we will be recovered heat there. Then for the night time, RFC will be generated this much, and this is the co-generated heat will be there. The overall efficiency of this whole system maximum possible is around 90.3% will be there. And the whole system, when we incorporate the, I will show you in the next slide that the system where we are going to redesign this whole system. So with that system, the overall around 70% overall efficiency will be possible there. So these are further results there related to the real-time energy gain, frequency, PV efficiency versus time, some panel temperatures will be there. So we have computed these results also there. And this is the overall system which we are going to develop there. So like you can see here hybrid PV thermal regolith fuel cell system for lunar basis will be there. So now what we are doing here, we are simply just during the day. Lunar day means one lunar day is equals to 14 earth days. Okay, that's why I'm telling you 14 days, because one lunar day is equals to the 14 earth days there. That's why. So during these 14 earth day time, what we are doing there, we are generating the electricity with the help of a particular solar PV system. That is fine there. Whatever the excess energy is there, what we are doing, we are going to supply in a storage form, thermal storage form, to this particular regolith is there. Okay, so we are supplying this here. So this whole will perform during the 14-day daytime there. Now, once the day is over and the lunar night will come there. So what we will do from here, we will simply supply this heat energy to this fuel cell system there. Okay. And with the help of this heat energy, this fuel cell system will be supply the energy during the lunar night time there. So like that system we are actually planning there. And if everything will be okay and it is according to our planning, up to 80% mass saving will be possible there. But the only thing is that we will just implement this system maybe first on the HIL, and then only we will just plan to just conclude some result on software basis. This system will be fine there, but maybe we are waiting for the results on hardware, that how much percentage efficiency loss will be there. Like here it shows 80%. Maybe when we are going to implement on the hardware, it can be reduced to 40% also there. So we are just waiting for those results there. So another task actually we are going to perform here is the optimal siting, which we already discussed there. And this is the actual flow chart for the optimal sizing and siting research we already submitted in some good journal, and soon that paper it's already revised and already in the acceptance phase is there. And for this purpose, what we are doing there, we are just creating some lunar environment. As I already mentioned, guys, that the maximum temperature possible is around plus 120 degrees centigrade will be there, and the minimum temperature is around 173 degrees centigrade will be there. So 28 days lunar cycle will be there, 14 earth days and 14th earth night will be there. It equals to make one lunar day, one lunar night together. Then we have some steady constant will be there. We will consider those constant there. And then the whole system we have developed for what purpose? Four crew member actually. The whole system actually developed for them only. And then we have defined two different types of loading condition also there. The first will be the critical loads. The second will be the non-critical loads will be there. So in a critical load, we have a oxygen generation. Definitely it is a must one. Otherwise the crews, those are living there will be died only there. So oxygen generation, CO2 production, and fixed load and a thermal control. Because why the thermal control is required? Because there is a huge variation in the temperature is there. So if we are not able to control the temperature of inside habitat, then it's very difficult for them to stay there. So these are the four critical loads are there. Non-critical load may be the lightning and schedule charging and discharging processes and some scientific payloads. So these three are what? These three are the non-critical loads there. Now, this information we will supply where? This information we will supply to the battery only PV system there. Okay, here we are not utilize the RFC system. We only utilize PV plus battery system there. So we have a different components here. Three different components will be there. What are those three components? PV array, lithium ion battery, and the battery management system thermal control will be there. These two controls will be there. So these are the control here. Then we have a what innovation we have doing here. So we will calculate the state of charge aware curtailment under 4 stages here. Thermal aware charging we have developed here, and then the modularity and the health monitoring we will be performed here. Then further, we will utilize the artificial intelligence technique for the optimization purpose. We utilize the grid search for the PV and the battery capacity optimization. So we will find these two terms here, and the SOC reserve of 10% we will find out here. Then in another term, the same critical loads data we will supply to regenerative fuel cell plus PV system there. So here also we have some components here, like we have a PV array, we have a PM electrolyzer for the particular RFC fuel cell will be there. Cryogenic hydrogen tank will be there because that is the must requirement in the fuel cell. Then PM fuel cell required, ZBO cooling is required, then closed loop S2 recycling is required. So these are the 6 components which we required when we have a regenerative fuel cell system will be there. Now, what new things we have performed in that? We will utilize the in-situ regolith shielding. We will perform there. We'll go for the ZBO design there, where we have processed the waste heat also. We again reuse it. Then again, the same thing, SOC aware curtailment we will perform there. Spherical tank with the ML1. We will just utilize them. Then again, we go for the optimization of this whole system there. Grid search, optimized value we will compute there. Optimized value of a state of charge we will find out there. After this, we have performed the simulation and then evaluate those simulation there. So we will perform on the hourly basis, 1 hour with a multi-sub hour subsystems there. Identical loads and environment we have created there. Different matrices for the mass reduction and the reserve requirement there, and the reliability calculation there. Then we will compare what? We will compare two things, battery with the RFC there, and then we will conclude the whole system there. So this is the one task we have already completed that. This is the second task which we have completed recently only. That is also under the revision phase in some good journals there. And in that we are going to develop the hybrid photovoltaic to regulate thermal storage and fuel cell based lunar microgrid, which we already discussed there. So here we have the solar, PV, fuel cell, and the regulate system will be there. Then we will find out the dynamic constant of this whole system here, analysis different constant there, and then we will find out the effects of a different parameters there. So we will supply this data where in the PV panel, habitat data, electrolyzer of a fuel cell there, and then hydrogen and the oxygen stored in the pressurized tanks will be there. This will provide the waste heat. This PV panel collect the sunlight, and then there is some waste heat there which we will supply to the PV and thermal panel there. From this electricity to habitat and the electrolyzer system, we will find out the electricity for the daytime operation there. Then from this electrolyzer, we will generate the hydrogen and the oxygen, and we will store there. Okay, so this water which we are collecting from this electrolyzer system there, we will process again with the help of electrolysis and again convert it into the hydrogen, the oxygen form there, and store in the tanks there. So this generated oxygen and hydrogen we will store in the separate tanks there. After that, we will thermal process in the photovoltaic, and the thermal panels will be there. So we will just embed the heat exchanger, hydrogen coolant loop, and then store in the regolith bed. So as I mentioned that the energy which we are collecting during the lunar daytime, we will store in the regolith bed will be. So after that, we will simply store this heat, store heat to the fuel cell, then habitat stabilization will be there. So when we will store these all the things, hello. So this information we will supply where then again in the lunar night operation we will be supply here, because we want electricity at the 14-day night time will be. So this whole stored energy we will supply where in this particular system, so that H2 and O2 from the tanks feed to the PEMFC fuel cell. Fuel cell generate the electricity here. Heat also generated, which we supply for the habitat there. Byproduct of water, again we will supply to the electrolyzer, and nighttime load operation will be there. So these all the process will be performed there. Then continuous electricity supply will be performed here. Okay, then we will end this particular simulation here. So this whole task we will perform. One more task recently we also perform here, as I already mentioned that we will utilize the different lunar space locations there. And here these are the 10 locations are there on the moon south pole, where skeleton crater is there. Okay, craters, different types of craters are there, but on the south pole the craters have a very good illumination profile. So that's why for this research we also utilize this particular south location there. So we have a 10 different location on the moon surface there. So first one is the Amundsen rim, second is the Fossey rim, Howard Malapert massif, Leibniz beta, Nobel rim 1, Nobel rim 2, Deoghar rim 1, Deoghar Kosif massif, then connecting risk. So these are the 10 locations. Actually, already NASA provide the location name for the moon surface there. So we directly take this data from the NASA website there. So these 10 location we will compute it, collect it. Then on these 10 location, what we have performed there, we have developed 4 different types of PV system configurations there. The difference under these 4 different types of tracking actually we will utilize. So for the first system, we use the fixed or stationary one. For the second PV system, we will utilize the triangular tent one. For the third system, we will utilize the horizontal single axis tracking. And for the fourth, we will utilize the 2-axis one. Okay, so like that way, 4 different types of tracking we have utilized there. And these 4 different types of tracking provide the 4 different types of answer there. So when we have performed these all the research here, we will supply this data for these 10 locations here. And then we have a different types of specifications here. Total 12 specifications we will utilize here, like latitude, elevation, annual illumination, maximum continuous darkness, horizon openness, mean solar elevation, then seasonal variation, ground range, albedo, optimized value of a temperature there, tracking DOF, and mechanism. So these 12 actually specification we will utilize. And this data we have just supply here for the resource descriptions, thermal environment development, configuration levers, and the performance and the sizing output. Okay, so like that way we have performed this. So when this all the information supply here, the input is coming here, where we have cross-validated these all the information using some error matrices there, like we have utilized here root mean square error matrix. With the help of this particular matrix, we have just find out that whether the particular model is correct or not there. Then again, we go for the stress test and the holdout one under the different winter and the summer extreme condition. Like in winter, we have a minus 173 degree centigrade, and in summer we have a plus 120 degree centigrade temperature there. So we will check them. Then analyzing this whole data out of these 10 sites, we will find out the which one is the best site there, and with which connection of these one. And then also we will find that which tracking will be the best power output will be there, or energy output will be there. So like that way, this task also we have performed, and then uh, already in the revision phase, this task also there. So these are the 10 sites which we have calculated there, and these are the results actually which we have computed under the fixed array, triangular tent array, horizontal single axis tracking, fixed tilt, and two axis one. So for each and every location, we have a 5 different types of results will be there. So first one is the collected radiation. Then second one is the PV cell temperature will be there. Then third one is the horizontal irradiation will be there. The fifth one is the ambient temperature is there. And the sixth one is the PV power. Okay, that how much the PV power. So this is under 4 different PV array tracking configuration is there. So we will compute under these 4 different PV array configuration. This is also calculated under 4 different PV array configuration. So we will utilize in this way for each and every sites. So this is the remaining 5 sites will be there. So total 10 sites. For the total 10 sites, we have computed this. After that, we have performed this comparative analysis also there. 3 different comparative analysis for all the 10 location, and for all the 4 tracking configuration we have performed here. Then we have find some results here, like the optimal site will be the Leibniz beta plateau will be there, and optimal tracking will be possible for the 2 axis one. So like that way, till now we have completed this all the task here. Recently we have also get some publication also in applied energy scientific report, and soon we are also getting in the electric power system research. And maybe in coming months we will get some good publication based on the work which I already discussed with you guys. So this is all from my side, and thank you very much for listening me patiently. And if there is any question from your side, it is most welcome. Thank you very much.
Thank you, sir. Participants, session is now open for questions. If you have any question, you may please unmute your mic and ask.
Hello. Good evening, Basim sir. This is Nilesh.
Hi Nilesh, how are you?
I'm good, sir. Sir, I have one question regarding the thermal storage at lunar surface.
Yeah.
You have shown one slide that there is one process from which we can store the thermal energy on the lunar. Can you provide some information regarding that? How we can do that?
Yeah, actually what we are doing that we are utilizing the regolith bed system. Means the the moon crust or the moon dust will be there, and we are planning to develop some thermal bed with the help of that particular regolith. And then we are planning to supply the heat during the lunar daytime and store in the form of like thermal storage system. Maybe we will make heat up this regolith, and then that heat we will keep it there, and when the night will start, then we will utilize that particular heat to supply the RFC there. So like that way, in this particular manner, we are planning to develop that particular system.
Okay, so one more thing. What kind of HIL you are using for hardware in loop simulation for these kind
Now
of
we
system?
actually in the lab we have a Typhoon.
Okay, sir. So Typhoon HIL,
So
it is possible.
yeah, Typhoon.
Because we have Typhoon HIL with our institute, so it is
Okay.
possible to do such kind of activity on Typhoon HIL.
Sure. It's if anybody of you wants to collaborate on this particular project, I am very much interested to just work on it. And if you people want, we can collaborate and work together on this particular topic.
Okay, thank you so much.
Thank you very much.
Any more questions, participants?
Hello. Hello. Good evening, sir.
Hello, good
Sir,
evening.
I was just inquisitive to know, like, what type of instruments are used to capture these lunar surface images that you had shown. Because when we are collecting the agricultural farm data, we are using the Landsat or the Sentinel data. But for this lunar data, what are those instruments like? How are these data being collected?
Actually, for the lunar surface, the data may be classified into the three categories. The first one will be the habitat load will be there. So the load consider the some critical instruments which require to generate the oxygen and water. So these two things will be required for the habitat loading will be there. When you are going for the laboratory load, because definitely when any space agency going to develop a lunar base station there, definitely they want to perform some research there. So under that particular laboratory, different types of apparatus will be there. There is a very good research paper is also available on IEEE, where the detailed uh, different types of load, what type of different types of load under these three categories available. We also refer that particular paper for the development of our particular model there. So in that particular paper, they will define different types of loads under the habitat system, different types of loads under the uh, your laboratory system, and then ISRO. So under these three category, they will provide the different types of load. So if anybody of you wants that particular paper, I will share you. You can also develop the similar load modeling for that particular system there.
Thank you so much, sir.
Hello, sir. Good evening, sir.
Good evening.
Sir, I am Dr. Prahat Kumar Ranjan
Okay.
from BIT Deoghar. Sir, what is the main conceptual difference between, sir, microgrids and nanogrids?
Actually, conceptual difference, maybe the amount of energy also generating, that is the basic one. When you have a microgrid, it's we have some amount of specification like the IEEE mentioned, it's some watt to some megawatt. So in nanowatt or nano microgrid, maybe you are going more smaller quantity of energy generation there. So that will be the first basic difference between the micro and the nano grid will be there. And maybe the second one, maybe the controlling and the applicability of a different type of system. Maybe I did not work on the nano grid till now, but I feel that this may be the main difference between them.
Okay, sir. Thank you.
Thank you very much. So is there any further question?
Sir, one more thing, sir. Sir, I don't want to ask anything, but sir, I would like to mention that your slides were very engaging and very interesting, sir.
Thank you very much.
Hello, am I audible?
Yeah.
There are more questions from the participant side.
Okay.
So, sir, I would like to thank you very much, sir, for graciously accepting our invitation and presenting your one of the topics of your research, the space microgrids, which was really very unique thing for us, and the basic difference between microgrids in space and what we are working here. So thank you, sir. It was very nice listening to you and getting an idea of the novel application of microgrid based power generation, scheduling things. Thank you very much, sir.
Thank you very much for inviting me such a nice FDP. In future also, if I will get the chance, I will come with more of my research insight. Thank you very much.
Sure, sir. Sure, sir. Sir, just one few minutes more, sir. Participants,
Okay.
just like practice we are doing in every session, I would request all the participants to switch on their camera so that we can take a screenshot, capture this moment with our resource person. Sir, please allow me few minutes. I have to take multiple
Okay.
screenshots.
It was nice presentation.
Yeah. Thank you very much.
Thank you, thank you, thank you very much.
Thank you, sir. Thank you very much, sir.
Okay. Bye.
Thank you, sir.
Thank you.
Thank you very much, sir. Thank you.
Thank you.
So, all the respected participants, this was the end of our first session for today. We will continue with the next session at 7:30 p.m., which is on patent and its applications by Ms. Kajal Priya, Advocate, Jharkhand High Court. We will resume again at 7:30 p.m. I would request you all to please stay connected. Excuse me, Kajal ma'am.
Hello, yes.
Uh,
Hello.
Good evening,
Am
ma'am.
I audible? Yeah, am
Yes,
I
ma'am.
audible?
Yes, ma'am.
Yeah,
Yes,
yeah,
ma'am. You're clear. Good evening,
yeah.
ma'am, and a very warm welcome to you in our session.
Thank you.
I just could you please share your screen so that we can check whether it is fine or not, means it is
Yeah,
working or
just
not.
a second, please. Yeah, just
Yes,
a
ma'am.
second. Is it visible?
Yes, madam. It is clear.
So,
visible.
is the slide visible? Patent and its applications.
Yes, ma'am. Yes, ma'am. It is visible.
So I'm moving downside. Is this visible clearly to you?
Yes, yes. It is changing.
Yeah, okay, fine.
Okay. Thank you, ma'am. We will start in just 1 or 2 minutes.
Yeah, yeah, sure. Hello.
Good evening to all the participants. We are we have joined again to start with our second session of today's. It is an honor for me to welcome our esteemed speaker, Ms. Kajal Priya, to deliver a talk on the topic patent and its applications. Ms. Kajal Priya is an advocate under the Bar Council of Jharkhand and a distinguished scholar in criminal law, currently pursuing her PhD at the National University of Study and Research in Law, Ranchi. She holds an LLM with specialization in criminal law from Chanakya National Law University, Patna, where she secured the highest grades in key subjects including criminal justice system, penology, and victimology, along with one of the highest dissertation scores in her batch. She has completed her BA LLB honors from National Law University, Ranchi. Her work spans drafting civil plaints, special leave petitions across criminal matrimonial service, commercial, and transfer matters, and hands on exposure to property disputes, ADR mechanisms, contempt proceedings, and e filing in the Supreme Court. An active academic contributor, she has authored numerous articles and book chapters on privacy, constitutional law, intellectual property, administrative law, and criminal jurisprudence. Her publication, A Conundrum Privacy versus Protection, features in a book that ranked among Amazon's top 100 bestsellers. She has also presented in national seminars on human animal conflict, environmental law, and elimination of violence against women. She is also a recipient of multiple honors, including the Best Paper Award by Legis Orbis and LexisNexis. I request Ms. Kajal Priya to please start with her session.
Thank you for the warm introduction. Kindly please tell me, is my screen visible and is my voice audible to me?
Yes, ma'am. The screen is visible and voice is also audible.
Thank you. And so, first of all, thank you for the warm introduction. It's pleasure interacting, learning, and discussing about this topic of patent and its application. So the very reason that why I have taken this topic, or why not only me, but for each and every assembled here, it is important to give a look and to think about and also to research about patent and its application is because like in my further slides I'll show that with time the patent applications is surging in India. Also, one of the important facts that is important to know, I presume that everybody who is assembled here is from, let's say, if is from BTech or from technical background. It is important to know about patent as well as design both, as if somebody, let's say, wants to switch their career apart from technical background to a little bit more of legal technical background, having the component of legal as well as technical background. So here comes the application of patent. If one is having the background of engineering, they can apply for patent agent examination. Patent agent examination, after they secure a particular marks, then they can, let's say, apply in a law firm. They can also become a patent attorney. So for that regard, not only for the purpose that we have assembled here for FDP, it is important to know what patent, but also for career prospects, it is equally flourishing, equally prospering. So patent exam, majorly, see, I want to discuss about this a topic about patent agent because many of the people, they later on realize that they should have done something in art stream or something related to legal. They have that enthusiastic approach towards it. And therefore, if one is having an extra edge over others, is having, let's say, knowledge about patent and want to apply somewhere as a patent attorney, then giving this example of patent agent is important. And here comes the application of patent. They can work in a law firm. Like, there are many biotechnological companies as well that they hire people who are having that knowledge, provided of course they have passed that examination. So patent and its application, my sole basis of telling about this like examination was that one should be having that edge over others in terms of knowledge, because knowledge is like never ending ocean. It can open number of avenues. So let's start about patent and its application. So coming to my first slide, it is stated by President Clinton that we live in an age of possibilities. 100 years ago we moved from the farm to the factory. Now we move to an age of technology, information, and global competition. So everybody knows that now the time is now the time of AI, artificial intelligence. But before like 20, 30, 40 years, have we ever thought that now humans will be replaced by artificial intelligence? No, of course not. Therefore, 100 years ago, we moved from farm to the factory. Then again, now technology, information, global competition. So this code is very much applicable, and in future, like here, it's like a never-ending dash dash dash. This means that global competition again in future something might crop. So we need to be in tune with the change, with the changes, with the demand that exists. So invention and discovery. So this is very basic that Benjamin Franklin may have discovered electricity, but it was the man who invented the meter who made the money. So any one of you can kindly volunteer and say in simple words, not in legal jargonish language, what is the meaning or what is the difference between discovery and invention? Anybody? I'll explain later on, but anybody can kindly volunteer and tell me. Any one of you may. Okay, so is my voice audible?
Yes, ma'am, it is audible.
Okay.
Participants may please respond.
Okay.
Government
Okay, so
something we need to find which is already
Yes,
exist.
yes, it is all audible.
yeah, okay. Thank you. Yeah, you may carry on, please.
Discovery
Hello?
basically,
Yeah,
hello, ma'am.
please.
Discovery basically means we are finding something that is already exist.
Yeah.
Invention means something we knew little bit.
Entirely new.
So any one of you more like anyone can more volunteer? After I'll state.
I think there is a small difference between discovery and invention. Discovery
Yeah.
is more related. Discovery is, I think, discovery is much related to available content, available sources already existing, and someone is seeking that, someone is found that by any process, by any means. And invention is somewhat more uh, not so many close. I think so.
For example, like discovery of gravity. This is the discovery. But
Yes,
invention
you
is
may say that. You may say that.
yeah,
Yes, yes.
a telephone invention, airplane, or many things. These are the inventions.
Yes.
Okay, so now I see almost everybody is on the right track only. So yes, you're absolutely right. Each and everyone is absolutely right. See, the different discovery and invention is important here to understand because in Patent Act, invention is protected, not discovery is protected. Because discovery already exists. It's just that somebody has found it out. Okay, so discovery is not protected. What is protected in patent is invention. Invention is something which is like application of one's intellect. See, intellectual property rights is a property. And what is a property? It is bundle of rights. Okay, so whenever somebody has that kind of an intellectual property, with that comes other rights. Okay, so let's say if somebody has applied for patent, so what as a automatic effect of it a person gets is right to protect it, right to harness the commercialization of it, right to assign it, okay, right to license it. So that is that we derive from invention because after all, what is intellectual property rights is intangible. We cannot touch it. It is something which everything which has to do with application of one's mind. Okay, so therefore patent act covers invention and not discovery. So almost everybody, each and every one of you was almost on right track. Just that patent protects invention. That was the point to be highlighted here. So the statute of monopolies. So like a little bit of history is important, that how today if we are having patent act 1970, of course 1970 as it dates, but before that we were also having certain other legislations. So actually my motive here is to make you understand in the simplest possible language without usage of any legal jargonish or legal maxims. So I know the very first impression that might have like you must have thought after hearing the term statute of monopoly, okay, what it is. So the statute of monopolies is nothing. Basically, it was a UK Act because everybody knows that India was ruled by Britishers. So it has effect of India had certain effects of Britishers. So in the form of law as well, we can see in the form of statute of monopolies. So statute of monopolies dates back to almost like 400 years back. 1624 was the year when Britishers they legislated the statute of monopolies, and the present Act of 1970 is a more better version of all of this legislation of statute of monopolies. So what I have stated in this slide is that the enactment of the statute of monopolies was a significant moment in the history of patent law as it set out fundamental tenets that serve as the foundation of modern patent system. As I stated, the Patents Act 1970, we are having it present. However, its significance is not just historical, the Australian Patents Act 1990 and the New Zealand Patents Act 2013 both refer to Section 6 of the Statute of Monopolies in defining what constitutes a patentable invention. See, I have highlighted it because patentable invention, not discovery. Okay, so patentable invention. So till date, in Australian Patents Act 1990, New Zealand Patents Act 2013, both refers to Section 6 of the Statute of Monopoly. But what is Section 6? Okay, so Section 6, what it states is that it sets out the following fundamental tenets of a patent system. Any invention must be new to be granted a patent, that is, any manner of new manufacturers. A patent is granted the true and first inventor and inventors. A patent protection is for a limited period. Actually, that time it was 14, now a maximum of 20. Even in India presently, we have that 20-year system. Okay. As we progress, I'll let you know about all these nitty-gritties. So the Statute of Monopoly, Section 6 is important and integral. In simple words, it states that should be new. So again, as we progress by, Patent Act 1970 also states as one of the essentials that the invention should be novel. Of course, even in like when we write research papers, we do a plagiarism test, we run Turnitin or any other, plagiarism tools. Why? Because anything that is out of our own creation, that should be, of course, like there's nothing legal application of it. It is like commonsensical. That anything that is out of our own creation, we have put our own efforts, that should be only protected. Hence, an invention must be new. New is the keyword here. Any manner of new manufacturers. Again, the second point is a patent is granted to the true and first inventor. Of course, it is also very commonsensical. That first inventor should be protected. Like why a second, third inventor should be protected? Not at all. So first inventor should be protected. And again, there is a particular limit to it. 20 years or even in Designs Act, Copyright Act, or there are also certain Trademarks Act. There is a certain time limit to it. Here it is 20 years. Even in India, we apply 20 years time. After that 20 years time, or let's say 14 years or 10 years for that matter in geographical indication or other IPRs, it is because after that it goes into public domain. Now people can harness the potential of it. Okay, so here it is important to know what state of monopolies, as I've stated right now. Again, the Paris Convention 1883. See, these all are little, boring, monotonous ones, but it is important. Like whenever you study.
Sorry to interrupt.
Yeah.
Can you please make it full screen?
Just a second.
Just okay. You can go to the, you can just click the icon just before that minus sign. If it is not working, you can try from here. The minus sign just beside that, we have one icon, just click on it at the bottom. Maybe it will work from here because we are unable to see that it is full screen. Is it working?
Is this
yes,
fine
this
now?
one. Yes. Please continue. Sorry.
Okay, not an issue. See, so yeah, just a second. Yeah, Paris Convention. So Paris Convention 1883, it states about the convention lays down a few common rules. So yes, so Paris Convention 1883, this is majorly an international convention which India has also ratified. So since India has also ratified, we also need to follow what the rules and guidelines that is stated in the convention. So it states about a few common rules that all contracting states must follow. The most important are that countries are independent of each other. So I'll give you an example. Let's say I'm in India. So I want to apply my patent in UK, USA, and India. So even if I have applied in India, doesn't mean that I need not apply in UK or USA or any other country. Each and every country has their own independent laws. Okay. So therefore, if I'm applying in India, I also need to apply in any other country individually as well for protecting my patents or my creation. Therefore, and where have I derived this independent of each other's principle? From Paris Convention 1883. Okay, so patents granted in different contracting states for the same invention are independent of each other. The granting of a patent in one contracting state does not oblige other contracting states to grant a patent. As I've stated, in simple word, this is as it is. Okay, same thing is written. A patent cannot be refused, annulled, or terminated in any contracting state on the ground that it has been refused or annulled or has terminated in any other contracting state. So the principles are different of different countries. So next slide. Yeah. So see, just a second. So yeah, anybody is having any doubt till here? You may kindly unmute yourself. Is there anybody having any doubt or any queries still here? Then I can proceed to further. Hello, hello. Am I audible?
Yes, ma'am, you're audible.
So if there is none, I can proceed. Or if there is any, anybody can unmute themselves if they're having any query. Can I proceed?
Yes, ma'am.
Thank you. Yeah. Hello.
Somebody was asking some question. You may please proceed. Ask the question.
Yeah, you may please.
Okay, ma'am, we can proceed.
Okay, fine. Or if anybody is having any question, they can kindly write it down in the chat box or write it down in a piece of paper. We can discuss it later on. Okay, I think that will be fine. So coming to the next slide, proceeding to the next slide. The Patents Act 1970. This is the law of the day. So Patents Act 1970 and the Patent Rules 2003 contains 163 sections. Total chapters are 23. And also I'll be telling a little bit about WIPO, World Intellectual Property Rights, and TRIPS, that is Trade Related Intellectual Property Rights. Before that, let's move on to further little historical historical background of it. It is important to know because then only we'll be able to appreciate how the time has progressed and today how the Patent Act is designed. Okay, so 1856 was the first year that we had our legislation about patent. So this was Act 6 of 1856. So whenever in a legislation it is written Act 6, Act 7 of 1856 or any year. So let's say if it is written Act 1 of 2025, this means that in the year 2025, the first legislation that was enacted by the government was this very act itself. Okay. So similarly, in the year 1857, Act 6 of 1856 was the act which was related to patent. So of course, that time we were not even independent, so we were under the colonial regime. So this act, what it did was introduce the concept of granting exclusive privileges for inventions for a period of 14 years. Okay, as I've also mentioned in my previous slide, 14 years was the time period that time. So then came 1859, Act 6 of 1859, rights granted to inventors. Then 1872, Patent and Design Protection Act. So in this very series, what is important to note is that with time we are adding new components to the Patent Act, and it is more refined. First, we had privileges, then came rights, then came patent and design, both. So I'll also explain a little bit of designs that, so these three, and again, we have that in 1911, Indian Patents and Design Act, Indian Patents and Design Act. Then in 1957, day after we became independent, there was a committee that was formed by Justice Iyengar Committee. And the role of this committee was to recommend and to keep in pace with the demand of the changing needs of the society. Because Patent Act is one act which has direct link to GDP, gross domestic product, or even the enhancement of one's economic status. Also, in many of the universities, the government is taking initiative of setting up of IPR chairs by DPIIT, Commerce, like in the like the Ministry of Commerce. They are taking initiatives. Why is this initiative being taken? Hello, was somebody saying something? Okay, so so why is this initiative being taken by the government? Because it directly reflects on our economic index. Okay, so Patents Act 1970 is the law of the day, and it is read with Patents Rule 2003. So the difference between these two acts and rules is majorly that, see, every time whenever, as I mentioned, that law should keep in pace with the change of the times. But every time, amendment is a very rigorous process. So for that reason, rules are sometimes legislated or sometimes rolled out, so that it's kind of an escape to the rigorous process of amendment. Therefore, rules are floated, and that is read in the consonants of the Patent Act, which is the Patents Act 1970. Okay, so that should be read in consonants. However, the Patent Act remains to be Patents Act 1970. Through that act itself, the patent rules is deriving its power. So it contains 163 sections, total chapters is 23. So yeah, moving forward. Patent, meaning, types, conditions, infringement, remedies, and case laws. So whenever we study law, there are certain sources. As I mentioned, Patent Act 1970, what it is? It is a legislation. Apart from legislation, what is also an equally important is the precedence. What precedence does is that it sets the rule. It sets the laws into motion. If there is any gap or if there is any need, then through judgments we can infer that what is the law of the day. So through case laws like Bear Corporation versus Union of India, Novartis AG versus Union of India, Vishwanath Prasad versus Hindustan Metal Industries, these are like actually there are many, but you being technical students need not know each and every case laws, but just for the sake of understanding, it's for the sake of what was said in those judgments is important to appreciate and important to understand. Okay, so what is the meaning of, let's say, what is the meaning of patent? I've been like from the very inception that I've started this presentation, I'm saying Patent Act, but what is the meaning of it? So patent is the word derived from Latin. So it has a Latin origin, which is whose meaning is to lay down. So it is derived from a word of Latin, Patere, which means to lay down, to make it available for people's inspection. Okay, so it is having a Latin origin. And then why is patent necessary? Patent is necessary to encourage research and development. As I move my slides, see just a second. There's important thing to highlight is, so see, intellectual property rights and development. This is the slide which answers why intellectual property is important. So the intellectual property protection helps in achieving, first, to encourage investments in research and development and sell newly created technology, commodities, and services. Secondly, the second purpose is to encourage and foster the circulation of new technologies for the development. So the intellectual property globally trend is that this is a source taken from WIPO. So patents in the year 2022, the number of filings was 3.46 million. Then 2023, it rose to 3.55 million. Trademarks similarly 15.55, 15.23 million, slightly declined. Industrial designs 1.48 million to 1.52 million, increase of 2.8%. Plant variety, an increase of 6.6%. Okay. So see, presently we are discussing with patents, so I'll be like focusing on that only. See, we can see an increase in it from 2020 to 2023. This totally highlights that people are becoming more enthusiastic. People are keen to invest their time and efforts in intellectual property rights. Even like I think many of you must have seen that very famous show Shark Tank. So whenever a new invention is like whenever people come and they say that okay, I have invented this thing, then clearly listen it and hear it. They also that okay, fine, I have applied for patent, I have applied for design. This is important because to protect one's creativity. However, it is important to mark that application for patent, it is not mandatory or even for any of the intellectual property rights. So like if I say that there is intellectual property rights as a heading, then subheading or under it is patent, trademark, copyright, industrial design, plant variety, semiconductors, geographical indications. So I am discussing about patent because that is very relevant to you presently. See, so so whenever these people come to Shark Tank and they say that I have applied for this, the impression that is casted on the judges is very positive because that gives an assurity that okay, fine, one must have done something very brilliant, one must have applied something very unique to their very invention, and that is the reason that leads sometimes to they fetching amount or they fetching amount from those judges. Okay, so patents we can see an increase. There's a surge from 2022 to 2023, percentage of 2.7 growth. Then yeah, so intellectual property and development. Rank in Global Innovation Index. India ranked 39th among 133 global economies in the Global Innovation Index 2024. In 2023, India ranked 40th rank out of 132 economies. India was ranked 46th position in 2021 and 81st rank in 2015. So what this highlights is that India is improving in 2024 among 133 39th. In 2023, India ranked 40th. In 2021, 46th, and similarly 81st in 2015. So it is a very positive news that people are becoming more aware. Okay. So government initiative also, government has taken very good initiatives. Make in India, National IP Awareness Mission. So yeah, National IP Awareness Mission is NEPAM. Then, as I have mentioned earlier as well, that there is chair set up by Ministry of Commerce. The chair on IPR is instituted by the Department for Promotion of Industry and Internal Trade, Ministry of Commerce and Industry, Government of India, with the vision to facilitate intellectual property education and research. Yes, was anybody saying something? Okay. I'll be moving forward. Yeah, so there are also certain theories, though not very much practical, but for the sake of understanding. Theories, intellectual property rights. So the theories is utilitarian theory, labor theory, personality theory. As the very name utilitarian, it's derived from utility, having usage. So there was a person named Jeremy Bentham. He was from Western world. So because the time that we got independence, many of the countries from the Western world, they have already progressed in terms of science and technology. They have invented number of inventions. So for that reason, there was a particular person who is a jurist, who, or you may say he is a very intellectual person. His name was Jeremy Bentham. He said that if something has a utility, if something has a purpose, that should be protected. So similarly, if we read in consonance with intellectual property rights, since one has created something which is having utility, having usage, therefore the intellectual property rights should be protected. Same goes with labor and personality theory. Almost similar in line in their reasoning is that if one has applied their efforts, I'm like continuously saying one thing, that applying efforts, applying one's knowledge, creativity is because of this very aspect of labor theory. Labor personality theory insists that personality is like very much related to to us applying efforts. That because from the time that we grow, we have been taught that one should study, one should put hard efforts, one should be very sincere about their studies. So this is in our personality itself. We are so much this is so much instilled as we grow, that it is ingrained, it is impressed in our mind that studies, or not any studies, but anything for that matter, putting our efforts into that very particular area is crucial to our personal integrity, personal self-respect. So therefore, personality and one's creativity, one's intellect are very goes hand in hand and are very closely knit, very closely related. And labor theory is also on the similar lines. So this was all the theoretical parts of intellectual property rights, the reasoning of why it should be protected. So I'll be discussing about just a second. So meaning type, as I've stated, that the word patent is derived from a Latin word meaning patron. So I have told about that why it is necessary to protect it. And there is also a case law, like I have mentioned in the third one here, Vishwanath Prasad versus Hindustan Metal Industries. So this case law, the Honorable Court has stated that the object of patent law is to encourage scientific research, secondly, new technologies creation, thirdly, industrial progress. A similar thing that I have just now stated. So now it is important that there's another case law of shining industries. I think I have not written, but just listen what was stated in this case law. So the Honorable Allahabad High Court in the shining industries versus Sri Krishna Industries has stated that an invention is not a property right unless it has been patented. It is due to this reason that inventors normally apply for patents and get monopoly rights. Yes. So let's say if I have created one invention and I have not applied for it, so that is something which is freely floating in the market, it is in public domain, then I cannot say to, or I cannot prohibit to the third, fourth, or second person that why this is my creation, why are you infringing it, why are you taking it into application. So applying it before the controller, I'll be like dwelling upon who is a controller and what it is all about. But the concerned person who is a patentee. So a person who applies for patent is patentee. So a patentee cannot prohibit a person unless and until he has applied before the patent authority, the controller. Okay. So conditions infringement remedies, I'll be again discussing about it. So yeah, so this is an example. Patent, trademark, design. So let's focus for the present time, patent. An invention on remote control mechanisms can be protected by patent law. Patent rights is valid for 20 years from the date of patent as new technology. So see, just like drawing a relation that you must have seen the word Sony written, Samsung written on your TV. That is a trademark. That has nothing to do with patent. patent is the industrial application of it. So I'll be dealing about the essentials of it now. So what it is that is granted, what is the invention that is amenable to the patent protection. So see, there are three important aspects. Just a second, I'm moving back to my slide. Yeah, see, conditions I'm discussing about. So first is novelty, second is inventive step, third is capable of industrial application. So what is novel? Novel is something new, which is not floated in the market. But how do a person get to know that whether it is like people are knowing about it, or whether it is being like freely floated in the market, it is open in the public domain? How a person can get to know about it before applying for patent? It is by virtue of a site. Okay. So there's an official site which is ipindia.government.in. This is the site in which every person's detail, as in his or her, their about their patent application is mentioned. Also, the category is also mentioned. So one can view from it whether that is already there in the form of protection, already there that have been granted protection. So of course, if before applying, one should view that site, because one's effort should not be wasted. One should apply their efforts in a particular direction that will yield a positive results in the form of commercialization. So it should not be in the public domain. In legal language, it is called as should not be in the part of a state of the art. So state of the art means simple language, but should not be in public domain. Okay. So second is the inventive step. So inventive step incorporates involving technical advancement. There should be some technical advancement, or having economical significance, or both, and should not be obvious to a person skilled in the art. So I'll be breaking all this. So inventive step, what it incorporates firstly is involving technical advancement, some technical advancement, or having economic significance, something that will yield some economic benefit to somebody, monetary benefit to somebody. Okay, so that is or both. So can have both or either of them, and should not be obvious to a person who is skilled in the art. So of course, a person who is layman or having no knowledge, for him everything is new. So we won't be taking into consideration that particular individual. We'll be taking into consideration who is having knowledge in that area. So if a person who is having a knowledge in that area and with that due efforts can think in that direction and finally leading to that invention, is something which is non-obviousness. So novel is the first criteria, first essential. Second is inventive step. So inventive step is synonymously used with the word of obviousness. So there was a case law in which it was held that inventive step and obviousness are similarly used. So again, this was the case in Vishwanath Prasad versus Hindustan Metal Industries. You may not note the very case law, but for the sake of giving an authority from where I'm from where am I deriving all those important important knowledge and important facts is from this very case law. Okay, so the Honorable Supreme Court held that inventive step is equivalent to word obviousness. So whenever somebody asks that what is in obviousness, then you may say that is synonymously used with the word inventive step. Okay, so the third is capable of industrial application. So what sets it different from from trademark is that, see, there are also certain other very vital important differences between trademark and patent, but among them one of the crucial is being capable of use in any industry and commercialization. So let's say if one has made an electric vehicle, so that is having some patent application, that patent component exists in that, because first that is novel, that is not freely floated. So the first time that somebody might have created with their application of mind that electric vehicle, that should be not known to people. Okay, So I'm giving an instance like through an electric vehicle. I'll be giving I'll be throwing light on all the three aspects and essentials. So let's take electric vehicle. So the first time that it was floated was novel, new. Secondly, inventive step involving technical advancement, of course. Some technical nitty-gritties exists in it. Having economic significance when used, it can generate some monetary benefits. Thirdly, capable of industrialization, commerce can be used for let's say like in let's say in some automobile sectors, even for anybody can sitting and then driving electric vehicle for any further purpose that can be used in industry, commercialization. So all the three exists. So I think so therefore it is suitable for the application filing of a patent. Okay. So there was a case law of Novartis versus Union of India. Again, see, patent application in biotechnology sectors have bloomed in recent past, and specifically after COVID times. So, like there are many companies that they recruit people who are having that knowledge of patent of IPR. So, okay. So Novartis is one of the biotechnological companies who manufacture medicines. Okay. So Novartis was in Union of India in 2013 case law. So there, what happened was that there was a certain medicine. I think that name was glycine. Okay, so Glyvic. So let's use the short form as G. Okay, so G Novartis have applied for applying patent for this very specific medicine, that is G. I will call it G Glyvic. Its full name is, and they have already applied for another medicine which is imatinib. So let's use a short form I. So since the matter was in the court, so what happened was that the honorable court they stated that since you are already having that I name product as a patent, why are you applying for G as a product? Because that is very similar. That what is argued that Glyvic represented a substantial innovation deserving of patent protection, citing its improved bioavailability and efficacy compared to its base compound I. So in simple words, I was having already that patent. Then why is G applying? Then why for medicine G the Novartis company has applied? So Novartis argued that not both are different. That is very Glyvic G is having a substantial difference from already applied medicine, that is I. So one important point here to highlight is that see all the laws derive authority from the Grand Norm. Grand Norm is the highest law of the land, which is the Constitution of India Act. The Constitution of India, Article 21, it states about, you may not remember the article specific, just for the sake of telling I'm selling, that Article 21 states that right to health is integral and it is very much related to one's day-to-day life. It is very related. So this I'm stating Article 21 of right to life because right to life and right to health as patent. And this very biotechnology sector has almost everything to do with right to health, right to life. So this was the point which was highlighted, that right to life or right to health is a very integral part. So whenever there is a conflict between the biotechnology or for any purpose for that matter, any company versus public health, then public health should be given priority. Even during the times of COVID, there were many companies that wanted to apply for patent, but the government told that this is the time that people should be protected. Their health should be given priority. So there is a specific section. So when this type of situation arises, the public health should be given priority over application of patent. So there is a specific section, section 83 of the Indian Patents Act 1970, which I would like to specifically state what it highlights is that granting patent to patentee is to encourage further invention and to protect any form of exploitation of the rights of patent holder. But again, I've said, but such grants should not act as a hindrance, but will rather act as an instrument to promote public interest. So public interest should be protected. Sorry? Was somebody saying something? Okay, so yeah, so public interest should be the priority. So again, one more important highlight in this case law, apart from public health versus the rights of the companies for protecting their creation, is section 3D. Okay, so there are certain apart from certain essentials, everything cannot be protected for patent. Okay, so I'll be progressing with the act. So section 3 of this Patent Act 1970 is important, that it says that everything cannot be protected. Evergreening, in like legal word, it is called evergreening. Evergreening cannot be done. Section 3D, it states that mere discovery of a new form of a known substance which does not result in the enhancement of the known efficacy of that substance, or the mere discovery of any property or new use or a known substance, or of the more use of a known process machine, unless such known process results in a new product or employs at least one reactant. Okay, so what, see, in simple words, section 3 of the Patents Act 1970, section 3D states that if there are two medicine, let's say in my present example, I and G, since I was already granted that protection, G will only be granted protection if G has certain substantial difference, not substantial, but certain difference exists. If both are similar, then why will the protection be granted? So section 3D states that just for the sake of granting protection, it cannot be protected to each and every aspect. Okay. So Novartis versus Union of India, in that way, is important to understand the concepts, both these concepts. Okay. So now coming to, yeah. So this is filing something. Yeah. See, jurisdiction for filing patent applications. The head office is Kolkata. So, but what are the factors that will be decided that how we will choose that, like whether I'll be applying for Delhi, Mumbai, Chennai, or Kolkata? What is the determining factor? So the determining factor is that where the people are living. So the people here also incorporates companies. Companies can also apply for their patents, or for that matter, any intellectual property rights. So that, as mentioned in this slide, is that Delhi includes Haryana, Punjab, Delhi, Himachal Pradesh, Jammu Kashmir, Rajasthan, Chandigarh, Uttar Pradesh, Uttarakhand, all those areas that is nearby to Delhi. Mumbai, similarly, Maharashtra, Gujarat, Madhya Pradesh, Goa, Daman and Diu, Dadar and Nagar Haveli, Chhattisgarh. Chennai includes Andhra Pradesh, Kerala, Tamil Nadu, Karnataka, Pondicherry, that is, I think, Lakshadweep Islands. So the rest of the states that is in Eastern India on the Kolkata jurisdiction. So this was the jurisdiction. So a person, let's say, residing in eastern part of India, need to apply in Kolkata. Person in Delhi area will apply in Delhi. Mumbai, Chennai, similarly. So this procedure I'll be like discussing on that later. Guidelines, yeah, patent process. Patent at 1970. Just a second. This will lead me to this patent act. Is this visible to everybody? Can anybody kindly unmute themselves and tell me?
Yes, ma'am, it is visible.
Yeah,
Visible, ma'am, visible.
Yeah, thank you. See, this is Patent Act 1970. Okay, so this is the legislation, the Patent Act. So what it states is that, as I mentioned in regarding one of my slides, the 39 of 1970, which means this is the 39th Act of the 1970s. So let's say there was a one act that was legislated in the month of January. That will be first. So February 2nd. So like not monthly, but depending on the legislature. So this is in the year 1970s. This is the 39th act that was legislated. The Patent Act 1970. The 19th September 1970 is the date of coming into force. 1970. An act to amend and consolidate the law relating to patents be enacted by Parliament in the 21st year of the Republic of India as follows. So, yeah. So this may be called a Patent Act 1970. It extends to the whole of India. So every part of India, this act is applied. It shall come into force on such date as the central government may by notification in the official gazette appoint. So yeah, this is not much relevant. I would like to take you to section 3. Section 3 is important. Yeah, see. What are not inventions? Okay. Inventions not patentable. So there are chapter 2 states about the following are not invention within the meaning of this act. An invention which is frivolous or claims anything absolutely contrary to well-established natural law. So let's say if there is a machine and the person is claiming that it has 100% fully effective, but there will be certain errors. So that is something which is against and contrary to the established natural laws. So this is what it states, that an invention which is frivolous or which claims anything obviously contrary to well-established natural laws. So section 3D, as I've stated, through that Novartis case law, that mere discovery of a new form of a known substance, which does not result in the enhancement of the known efficacy. Okay, so if there are two medicines, through that I've explained. So yeah, you may also read this one. So yeah, so again, section 3B, an invention, the primary or intended use or commercial exploitation which could be contrary to public order, morality, or which causes serious prejudice to human, animal, or plant life or health to the environment, that cannot be protected. So what are not protected is firstly frivolous or anything which is contrary to well-established natural laws. An invention, the primary or intended use or commercial exploitation which could be contrary to public order. Mere discovery of a scientific principle or the formulation of abstract theory or discovery. Yeah. So as I have in the initial of my slides itself, as I've stated that that discovery or invention, not only I've stated, but I have also asked from you that what is the difference between discovery and invention? It is because the discovery is not granted the protection of patent. And here as well, it is stated that mere discovery of a scientific principle or the formulation of an abstract theory or discovery of any living thing or non-living substance occurring in nature, that is not granted patent. Okay. So, so the sole purpose of showing this very act is to show that how to read firstly that act. Okay. So when we see that Patent Act 1970, it progresses like this. And so first is the Patent Act name. Then secondly, the chapter 1 preliminary, short title, extent, commencement. Very simple and very easy to understand. Secondly, definitions. It's very clearly and elaborately written what it is. Okay, so it states about it, and it also states about what is patent. See, section 2M states patent means a patent for any invention granted under this act. Okay, so not very elaborately stating, but for the sake of understanding, as I've mentioned right now, what it incorporates, what it is. So reading in the backdrop of this, as stated in section 2M, will make you understand and appreciate that what patent is. So it is very elaborate. See, me discussing it's around 109 pages. Me discussing 109 pages will of course take a lot of time. Also, see, knowing each and every aspect is not very necessary, but essential ones, important ones, each and everybody should know. So section 3, kindly note that what is not invention, it states each and everything. For example, a literary, dramatic, musical or artistic work or any other as aesthetic creation whatsoever, including cinematographic works and television productions. Why I have highlighted this one is because it is already granted protection under copyright. I have not dealt with that, but like kindly for a second think about in this way that it is already granted under copyright protection. Then there is no necessity of it being granted protection under Patents Act 1970. Similarly, integrated circuits, it is already granted under semiconductor. There is a particular act under the heading of semiconductors and circuits, integrated circuits. So that is already granted. There is no need. So traditional knowledge, which is an aggregation or duplication of known properties or traditional known component, because there is already a certain act. Plants and animals, there is a Plant Variety Act. The mathematical or business method or a computer program per se or algorithm, see, certain things are also not protected because the government wants that it should be in public domain. Okay. So through that case law, Novartis versus Union of India, as I mentioned, public necessity versus the company or the individual's patentees, right? Public, by virtue of Section 83 of the Patents Act 1970, will be given a right, will be given a precedent, will be prevailing. Okay, so mathematical or business method or a computer program per se, that is also not protected for the reason that it should be in public domain. People need it. Okay. So a substance obtained by mere admixture resulting only in the aggregation. So let's say there is the umbrella. There is an umbrella. There is another component attached to that umbrella is a fan. And apart from that fan, there is another component, let's say light. That ultimately is leading to nothing. It's just that we are adding more components to that very umbrella. So mere admixture, adding and resulting only in the aggregation of the property of the components thereof will not be granted protection. That actually should result in some application. That is not in adding any application. That is simply like adding things together. Okay. So yeah, so I have dealt all the method of agriculture, horticulture, again, not provided. Medicinal, surgical, therapeutic, or other treatment, human beings or similar to animals to render them free to increase their economic or their say. This is covered in the 3I, that is also not given protection. Invention related to atomic energy, not patentable. So applications for PIN that I'll be delving later on. So yeah. So this was about the act. Now moving forward. So see, apart from this, like patent, as I have also given brief, told a little bit about a brief introduction about what is industrial design, semiconductors, trademark, geographical, but just given a brief, taken a name of it actually. So you may kindly see that copyright, the Patent Act is Copyright Act 1957, patent, designs, not very much essential for now, but just for the sake of understanding and seeing it, you may kindly take note of all these acts and legislations. IP laws of India, Copyright Act 1957, higher education, these are the ministries that govern. Evolution, like Paris Convention, as I've stated. Similarly, for other conventions, there are other conventions that dwells for other intellectual property rights as well, like for Hague Agreement, Nice Agreement, Lisbon Agreement, so Budapest. These are certain agreements. See, it's a World Intellectual Property Organization. Was created to promote and protect intellectual property across the world by cooperating with industries as well as international organizations. It is headquartered in Geneva, Switzerland. India joined WIPO in 1975. So see, what this very organization aimed to do is that to promote intellectual property throughout. Like we have certain, I took the name of NIPAM. Okay, then as Ministry of Commerce, there's in our country, but how far the world is concerned, there is a particular organization, WIPO, which caters to the need of people by promoting and protecting intellectual property and creating awareness throughout the world. Yeah. So this is about that. See, this is yeah. So I'll discuss more about it in regard to, yes. So see, I'll tell more later on. I'll show all these slides, but let's dwell a little bit more on patents. Okay. So I mentioned about essentials. I mentioned about section 3, what cannot be protected. I mentioned also about historical aspects. What is the meaning of patent? Now, in this slide, World Intellectual Property Organization. So apart from all this, the application is important. Okay. So let's move backwards. Applicant. Okay. So true and false inventor or assignee or legal representative separately or jointly may find. Okay. Application, one application in prescribed form for one invention in appropriate jurisdiction. I told about appropriate jurisdiction and prescribed fee. Okay. So prescribed fee I have mentioned in my slide. Patent fees and conditions. So I have taken this from authoritative site. So what is mentioned in this very slide is that action, filing of patent application along with complete and provisional specification. See, what is complete and provisional specification? So it happens is that when we apply for patent, there are certain jurisdictions, as I mentioned, Delhi is there, Kolkata is there, Mumbai is there, Chennai is there. So let's say if I have to apply in Delhi. So I applied in Delhi, then it may happen that I have not reached the final conclusion of my research, but I'm pretty sure, I may be decent sure that I'll be reached to my complete research in a year. So for that reason, I have provisionally applied before the authority of controller. So, and mark my words that here 1 year term is important, because if in that 1 year term, if I have not fully completed my research, then my provisional application will be rejected. Okay, that will be revoked. So sometimes, see, this is like, it may come, this question might come to you, is that why is there a provision of provisional specification? See, this is done because the time that now we are living in is like every country or every person wants that there should be, enriched with knowledge. Even government wants that in the similar lines. So therefore, to promote people like using their intellect, to do something creative, therefore there is a provision of provisional specification. And also one more reason is that if person has progressed to that extent, then people might presume that, okay, fine, they'll be able to reach to complete to the extent of completion. The complete specification or provisional specification, limits and conditions and timelines for maximum number of pages 30 and maximum number of claims 10. Individual 1,000, legal entity 4,000. Legal entity means like companies. Okay, they can also file for patents. So see, maximum number of pages. What is here pages? The pages here is like, so like similar as we write a research paper, we are also supposed to write patent application, what it is, and like the drawings or the claims, very detailed one need to write the specification, like why it is patentable, what is the novelty aspect in it, what is the industrial application in it. So, okay, so what is non-obviousness in that very patent? One need to write in a very elaborate manner, and if there is any drawing, one also need to like paste that or draw that diagram, images, whatever it is. And number of claims. Claims is that like for what they are asking for, like for what purpose or for what points on which they're asking their very invention to be protected on. So for each additional sheet, it may happen that they want more, so they're writing more. So for each additional sheet, rupees 100, 400 for legal entity. Each additional claim, more claims if they want. So similarly, renewal fee starts from second year. Okay, so the patent is granted to 20 years. The timeline is 20, and the renewal fee every year is to be paid, and it starts from second year. Second year to 6th year, then 7th year to 10th, 11 to 15, 16 to 20. So this all is written. Okay. So yeah. So yeah, one more important aspect is patent cooperation treaty. So as the very name highlights, treaty. So like there are certain nations coming together. So what happens is that apart from the very principle of Paris Convention, which states that every nation should have different laws of patent, but there is a patent cooperation. So the cooperation, okay, as the very name highlights, there are certain countries who thinks that okay, fine, even if one of the nations, one person has applied, that will be considered that they have applied in like these nations. So there is a treaty. They have come together and they have like written it down in the form of agreement. This very condition is that one has filed an application at one place, that will be considered as they have filed in these jurisdictions and these countries as well. So for that, these are like, see, in international currencies it is mentioned. So these are the certain, this is like the cost of filing a PCT application by an Indian applicant as is as follows. Okay, so this is the one regarding fees. So payment if filed electronically, this is the one. So similarly on those grounds itself, similarly, the thing that I mentioned, it is written in that very slide. So yeah, process. Filing of application, provisional or complete. I told about the meaning. Then publication of application. It is published. Okay. So request for examination of FER, grant of patent. So yeah, this is the very process, and with time it is mentioned promptly after 18 months, within 18 months. Okay. So this is not very important for you to understand, but it is but the thing that I'm stating here is that, see, all it starts with a filing of application till the grant of patent, and that can also be applied, that can also be appealed. Like if somebody is having any objection, they can also do pre-grant objection, pre and post. So pre is like before grant and post is after grant. So pre-grant, post-grant means that the moment it is published to the people can view it. So in that very site that I've mentioned, people can view all those patent applications. And if somebody is having any objection, they can object. So that is pre-grant, before that. And post-grant is grant of patent. Grant of patent, if one is granted patent, post 1 year, the objection can be raised. So this is important to highlight, that filing of application, publication of application, not serially like learning verbatim is important, just for the sake of understanding, note down the process. So yeah, so see, section 7, apart from section 3, section 7 of the Patent Act 1970, it highlights about the form of application. So according to section 7, every application for a patent shall be for one invention only. Okay, so one invention only. The application is to be filed in the patent office. So territorial jurisdiction, as I mentioned, is that it is based on place of residence or domicile or business of the applicant, or place from where the invention originated. Okay, so that is the determining factor. So yeah, so this was about little about patent. Apart from it, yeah, also one need to know a little bit about, see, there are also intellectual property rights apart from patent. Is geographical indication, not very applicable, but yeah, not very relevant to you, but of course applicable. So like in Bihar, we have handicraft Madhubani paintings, Katarni rice, then Bhagalpuri Zardalu handicraft cover paintings. Then see in the map, of India. There are but what is the difference? Like, what is the essentials of geographical indication? Is that like also Vellore, Spinny Brinjal, Tamil Nadu. So what geographical indication is that, as the very name again highlights, a geography. So if let's say if there is a particular area, let's say Darjeeling tea, people throughout the India loves Darjeeling tea. So from a very specific area, that product is coming out. Also, like one important essentials apart from is like through the example of the Kanchipuram sari. So from the southern part of India, we have the Kanchipuram sari. So people from that very area is so knowledgeable, so skilled in that very art that people know about like those very like nitty gritties about the how the way sari is made. So it is more about geographical aspect. So yeah, patent I have mentioned about meaning. So I'm not dwelling more on geographical because that is not very much relevant. And my topic was also patent. Okay. So yeah, discovery difference between discovery and invention. We have already discussed about it in previous slides. Designs. See, design is important because see, patent and design. Earlier, we had patents and designs at 1911. They are related almost. So, but post 1911, these two were like segregated, and we are having a design act specifically. So, in short, if I have to say what is design, is all about the looks configuration. Okay. So let's say when we see a flight like there's a conical portion in the very front portion of aeroplane. So this is a part of design. Why? Because it cuts the atmosphere very quickly, and as a result of it, the aeroplane or the flight moves very fast. So that for that reason, what is design is all about the looks, configuration, the aesthetic quality. It has not to do anything with the application. Unlike, as I mentioned in my patent slides, that patent has certain industrial application which is not there in the design side. Okay. Apart from essentials, if I have to say that same almost thing, that novelty is there, then it should not be present in the public domain. Okay. Yeah, so one more thing actually in patent one should know is about the rights. Okay, so yeah, forgot to mention it. Let's go again to that slide. Just a second. Yeah, I think it's not opening or what. See. The provisional or complete specification, as I have mentioned, section 9, simple words, I have stated all those important things. There are also further important aspects, but not very much relevant to you. Provisional and complete specification, or if anybody wants to read and have that inquisitiveness, then you may kindly read this act. Patent Act 1970 is very well written and very elaborately in a very lucid manner it is stated. Everything, contents of specification, what it should be. Okay, fully and particularly describe the invention, disclose the best method, end with a claim, be accompanied by an abstract technical information. Okay. Publication of application, as in one of my slides I've mentioned about it. Just a second. Just a second. I think there's some issue. It's coming a little bit blank, but okay, fine. I'll tell you what it is. Okay, so actually I was referring to punishments. Okay, so what if there is a particular person who infringes someone's patent? They have already applied it, but even though somebody infringes, what is the remedy? So the remedy is there that they can apply to a court. Okay, so by applying to a court, what they can, as a really matter of relief, they can get is the injunction. So injunction is like stay order. Like commonly we say in the common language, common parlance, that stay is imposed. So but in legal term we say about injunction. Okay, so injunction, temporary, permanent injunction is there. So temporary, like for the time being, permanent is sometimes the situation such that the situation mandates us that very urgently one need to restrain that particular person. If not, then that particular person might commercially harness the potential of that patent. So for that reason, injunction is imposed, permanent or temporary. That is totally on the discretion of the court. Okay. So that was the punishment. Majorly injunctions, also sometimes seizure is done. So these are like few of the remedies that is available. Then see, this is trademark and all, that is not very relevant to you, but copyright, plant varieties are mentioned. See, yeah, this is important. In this very slide, I have mentioned what is patent, design, trademark. Okay, not very necessary. So patent is this very camera itself, how it captures the autofocus mechanism. So this mechanism can be commercially harnessed. Okay, so this is the subject matter of patent. Design, as I mentioned, it is all about appearance, the aesthetic, the looks. So the subject matter design, external appearance of camera. And trademark, I think not very legal. I have not explained of course about the trademark, but of course by your common knowledge you must be knowing that Canon or Samsung or any for that matter is the trademark. Okay, so patent, design, mentioned. World Intellectual Property Rights Day is observed on 26th April. The day aims to raise awareness about intellectual property rights and innovation to make the world a better place. The theme of 2025, IP and music, feel the beat of IP. So music is covered under copyright. So I have not discussed about that, but because the topic is about patent, but IP and music. So music is one of the components of the IP. Okay, that was the theme. So yeah, so Designs Act, it's all about looks. See, this very like pot, the clothing, the configuration. Well, this is actually a trademark, not I have not discussed classification of design. So there are also designs classification under which subclass. So that is actually done by the controller who allocates the class of it. So that is trade secret, IP can be written. So yeah, similarly, all these kinds of geographical indications, examples of geographical indications. Yeah, similarly, this all. This. Okay, so this was all from my end. So if any, now the floor is open. If anybody wants to ask any question, they may kindly ask. Okay, so yeah. Hello, am I audible?
Yes, ma'am, you're audible. Participants, the session is now open for questions.
Hello, ma'am. I am Adarsh Pratap Singh, and ma'am, I have a question.
Yeah.
I want to discuss that as an engineer, when we are engineering or developing a new product using an open source approach, ma'am. So how can we still use patents to protect our work without breaking the open source philosophy? And is there any specific type of open source licenses that allows sharing while still letting us keep some control or power with our patents or our works?
Yeah. See, there are certain exemptions for researching. One can use other patents. Okay, so for other information, one can, so for researching, as I mentioned, one of my slides, Bayer corporations. For that is a case which say that researching. So if let's say I want to research on something, then I can use another's resources. But for commercialization, I cannot. So what is not permissible is not commercializing. And also one can view from that IP, that IP government.in site, what is granted as patent. So one can view, and according to that, one can utilize, or one can wisely use that very patent. Patent. So that was. I hope that I've answered your question.
Okay, ma'am. Thank you, ma'am.
Good evening, ma'am. Ma'am, as you're talking about the patent, who truly benefited from a patent, the inventor, the corporation, or the public?
See, who benefit is actually the see. It happens that the particular person, since he or she has applied their mind, then that is the person who is getting benefit. But the thing is that like through commercialization, they can give to license to anybody. Okay, so if there is electrical vehicle, then they might license, because that is their whole and sole product. Also, how far other people are concerned, then as I've stated, that public versus people, sometimes because of the need of the public, then like let's say an important drug, a cancer drug, it is for public utility. So for that reason, public benefit or public rights, that is given precedence to other. Yeah.
Okay, ma'am. Thank you, ma'am.
Ma'am, good evening, ma'am. Hello, ma'am. Good evening, ma'am.
Yeah. Yes, speak.
My name is Naresh.
Yes.
I'm working as a STEM professor in Peace College of Engineering and Technology, Andhra Pradesh, ma'am.
Yeah.
Ma'am, if I file the patent and I've taken the patent rights, means repatent, for taking of repatent, maybe the patent rights, if I purchase, if I taken 20 years, if I need to take repatent, what I need to do, ma'am?
Repatent is allowed, okay, but there should be certain significant differences, okay, that should be there in the form of that invention that you have created, okay. So for same one, sometimes it also happens that paying the extra money, that can actually grant, but mostly it is not, okay. So mostly it is not, but if you want to repatent is, then you have to apply again with certain significant differences that already existed in your first or previous patent.
Means by doing a little modification, again I taken, again I can
Little
take
modification, not very significant, but a person who is skilled in the art should actually be not able to derive that very new qualities that already existed in your former patent, okay. So that person should not be able to bring out that innovation, that novelty in, okay. So that repatent is allowed, but of course the different certain qualities should be there.
Okay, ma'am. Thank you, ma'am.
So any more questions, if anybody can ask, the floor is open, or we can call it an end. If anybody.
If any participant has any question, they may ask. The floor is still open. Ma'am, I think there are no more questions from the participants. So I think we can wind up this session now. So on behalf of the organizing committee, ma'am, I extend heartfelt thanks to you for graciously accepting our invitation and presenting such a informative and detailed presentation and talk on the topic of patent. Thank you, ma'am. Thank you very much. And I request the participants to please switch on their cameras so that I can capture some snapshots, some screenshots to capture this moment with our resource person. Please, participants, very few people have switched on their cameras. It will take few minutes. I have to take multiple screenshots. Please bear with me. Thank you, madam. And thank you all participants for switching on your cameras for a few minutes. Thank you, madam, for such a detailed session. We will look.
Thank
We
you,
surely
ma'am.
will look forward to have more such sessions in future. Thank you, ma'am.
Thank you. My pleasure. Thank you.
Thank you, madam.
Thank you, madam.
And
Okay,
dear
thank you, ma'am.
participants, dear participants, this was all for
Thank you, ma'am.
today.
Thank you, ma'am.
Thank you, ma'am.
Can I leave now?
Yes, ma'am. Okay, ma'am.
Thank you.
Thank you. So, respected participants, that was all for today. We will again join tomorrow at 6 p.m. as per schedule. And the feedback link for today's 2 sessions will be sent tomorrow. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.